Hi everyone, my name is Dhanya. Today I am going to show a presentation about single linked list. It's important to store the data in a particular order in our daily life. Similarly, in C programming, in order to save the data in a sequential order, we can use arrays or linked list. So in this presentation, let's learn how to maintain data using linked list. Linked lists are the most common and simplest data structures. Linked list is a linear data structure that includes a series of connected nodes, and each node consists of two parts, the data part and the link part. The data part contains the actual data of the variable and the link part contains the address of the next node. So we use the head node as a pointer to initiate the single linked list. So the address of the first node given is called as a head, and the last node of the linked list can be identified by the null character. It signifies the end of the linked list. So this is an example of a linked list. So it's a sequence of nodes that containing two fields, and here the last node is linked to a terminator, so it's used to signify the end of the list. So a single linked list is a list of nodes basically, and linked lists are of three types based on the characteristics. Single linked list is unidirectional, and double linked list is bidirectional, and circular linked list, the address of the last node is connected to the first node, so it's a continuous linked list. So let's see how each node of the linked list is represented in C program. And we use self-referential structures. And in C language, a linked list can be implemented using structures and pointers. And to create a structure, we use self-referential structure. So a self-referential structure is a structure which contains a pointer to a structure of the same type, so the function calling itself. So let's see how to create a structure in a linked list. So declaring a linked list, we use structures to create a linked list. So in this example, we are using struct linked list, and int data we can use int or character or float in any data type, and struct linked list pointer to the next node. So next is equal to the link, so it stores the address of the variable and it points to the same structure, so it's a self-referential structure. And we will use self-referential structure for creating a node of a single linked list. So let's see how to create a node in a single linked list. This is the basic syntax of creating a node, and in structures we use extra header file called as stdlib.h. So the first step is like declaring the structure, and we are taking a temporary variable pointer and allocating the dynamic memory allocation to the temporary pointer using malloc, and it's a dynamic memory allocation. We can use these dynamic memory allocations in linked list. So linked list is a dynamic in nature. And we are giving the link part of the temp is equal to null, and return temp so that the node is created, and the link part of the temp is equal to null. So let's see how to traverse in a linked list. This is important to when inserting or deleting a node from end. So a linked list can be traversed here in a while loop. So let's use head node as a starting reference. So P with a temporary pointer. So using while loop, so the pointer P goes until it's not equal to null, and so that pointer of link is equal to the temporary pointer P. So in this method we can linked list. Let's see how to insert in a single linked list, and this is the basic syntax of how to insert a node in a single linked list. So we are taking the temporary pointer and temporary pointer temp and P. So let's assign the temporary of data is equal to some value. We can type any value here, and if head is equal to, head means the first pointer, if it is equal to null, head equal to temp, the temporary pointer becomes head node, becomes the first node, or else the temporary pointer, another temporary pointer P is equal to head, we use traversing. Now let's see how to traverse in a linked list. The linked list can be traversed using a while loop by using the head node as a starting reference. Let P be the temporary pointer, and by using while loop until P is not equal to null, the P pointer traverses to the last but one node, and the link of the temporary pointer becomes the pointer. This is how we traverse a linked list, and it's very important to insert or delete a node from the end. Let's see how to insert a new node. This is the basic syntax of inserting a new node. For inserting a new node, let's consider temp and P as the temporary pointers, and temporary, let the new node is equal to temp, and temp of the data is equal to some value. If head pointer is equal to null, that means the list is empty. So head is equal to the temporary pointer becomes head, or else the list is not empty, so the head pointer becomes the temporary pointer P, and the link part of the temporary pointer P becomes P. So this is the part of traversing to a linked list, and we return the head pointer. So this is how we insert a new node in a linked list. Let's see how to delete a node from a linked list. So this is the syntax of how to delete a node from the beginning. So initially we have to point head to the next node, and there is no need of traversing because we are deleting from the beginning of the linked list. So the temporary node temp points to the head node, and the link of the head node points to the head node, and we can just free temp. This is the dynamic memory allocation which is used to delete the node. This works only in linked list, the dynamic memory allocations. We can use delete temp or free temp. So let's see how to delete a node from the end. So to delete a node from the end, point the head node to the previous element, so the struct node, the pointer of the end becomes head, and the previous node becomes null, and we are using while loop. So while loop until the end, the link part of the end pointer. So end is equal to previous, and end of the link is equal to end. Now let us see how to delete a node from the end in a linked list. initially point head node to the previous element, that is struct node of pointer end is equal to head, and assign null character to the link of the previous node. So we are using traversing here because we are deleting a node from the end, and after traversing assign null character to the link of the previous node, and you can use dynamic memory allocation free to delete the end. This is how you delete a node from the end in a single linked list. So we use linked list over arrays. Now let us see advantages of single linked list over arrays. So linked list, being the dynamic data structure, can insert or delete any node by deallocating or reallocating memory. So there is no need of declaring an initial size in linked list, whereas in arrays we have to declare the initial size. And linked list are very helpful data structures like queues and stacks can be easily implemented using linked list. And insertion and deletion operation is easy in linked list when compared to the arrays. And memory usage, there is no memory wastage in linked list. In arrays we have to first initialize it with a size so which we may not fully use, hence wastage of memory may occur. So these are the applications of the linked list, and thank you for watching.